on modern airliners, sitting in front of this rather impressive panel on the left-hand side, or my left, is the flight engineer, or was the flight engineer.
Jeez.
Instruments on Concorde, exactly the same as you'd find on any other aircraft. The only dial of interest really on the flight panel here is the Mach meter, which showed you when you reached supersonic speed and beyond. Concorde used to fly Mach 2.2, just over twice the speed of sound, 1,350 miles an hour, faster than a rifle bullet. And of course this is 1950s, 60s technology, not 21st century technology. Same panel on my side for the first officer. He also has the lever for the visor and the nose. The only reason the nose moved was so that the pilots could see the runway. And the landing lever also on his side, in between. 4 engines, so a set of instruments for each of the 4 engines. Inputs for the inertial navigation system here, VHF radios, weather radar input over here with a weather radar screen over there, and the black lever in front of that was the lever for turning the nose wheel while on the ground. Now I'd like you to imagine you're sitting at the end of the runway ready to take off. The engineer has his seat turned round between the 2 pilots. He has one hand on the throttle, as does the pilot who's doing the takeoff. When they get permission to take off, the engineer would press the white buttons here, which are the reheat or afterburner buttons. All that does is pour raw fuel into the jet exhaust for extra power, but of course it's very wasteful, so it's not used for very long. 3, 2, 1. The 2 of them together push the throttle fully forward. Naught to 250 miles an hour in about 14 seconds or so. It's fairly fast. 0 to 2, as I say, 250 in about 14 seconds. Steep take-off and climb out. Once they're established in the climb, they can, if they wish, take advantage of the autopilot equipment, which we've got up here. Press Alt hold, for example, and the aircraft would hold at altitude until they're told it to do something else. Supposing they were going to New York, but it's too foggy to land the aircraft manually in New York, no problem. All they had to do was press the auto button, sit back, fold their arms, and the aircraft would land itself at about 190 miles an hour. Assuming this is a fairly normal flight, the engineer is monitoring all his systems, of course, over on the left-hand side, my left-hand side. But in particular, he's pumping the fuel around the 13 fuel tanks to keep the aircraft balanced, and also to help keep it cool, because the cold fuel quite near to the top of the wings absorbed a lot of the sun's radiation, and they put it through a heat exchanger, cool the hydraulics and oil down, and then pump it to the cabin air conditioning system. Now, travelling at 1350 miles an hour, a lot of heat builds up because of friction. The aircraft was designed to expand between 8 and 10 inches. The expansion was most clearly seen at the end of this panel here. You see the blue label where it meets the bulkhead. Small gap there at the moment. But as you can see in the photograph, at supersonic speed, the engineer could actually stick his hand in the gap.
Down there.
Can you see?
I see.
Yeah.
Right.
Okay.
The expansion.
And on the last flights of several Concordes, the engineers stuck their caps in the gaps and left them there for posterity, because of course once the aircraft cooled down,
Lock them in.
the only way they could get them out would be to cut them out. So that's Concorde's flight deck for you.
Awesome. So much to watch. Can't set the radio on the car. Yeah. Sums it up, doesn't it? Oh, the whole pile of stuff up here.
Well, it's like everything else. It looks complicated, but you're not using it all at the same time.
No.
And actually, the flight engineer's job was more complicated than the pilot's job. And their training was longer than the pilot's.
Training?
And British Airways had a policy. It wasn't suited to everybody. And British Airways had a policy that any engineer who did the course but failed it went back to the aircraft he was been flying on before, but no mention of it was made on his record. It wasn't treated as a black mark against him.
Because it was so difficult.
Some engineers were suited to it, some weren't.
Right. Yeah. So,
because there was a lot of